Good afternoon, everyone, and welcome at this webinar on the socio-economic impacts of COVID-19 and the journey to vaccination. It's a very actual and very interesting topic, and that's why I'm very happy that Avertim, our partner for this webinar, was willing to be here with us today. Anita van der Swan, Laura van der Tol, and Lucas Seringer will be speakers today. And yeah, in preparation to this webinar, I was very excited because a lot of questions came up only by just speaking about the preparation of the webinar. So I cannot wait to listen to what Anita van der Swan is going to tell us today. So Avertim is a European innovation and management consulting firm. They're active in the sectors of life sciences, banking, energy, telecommunication and transportation. And in the sector of life sciences, they're active not only in the Netherlands, but in Belgium, in France, and in Germany. So Anita van der Swan is going to be our main speaker today, and she's gonna tell us all about the different impacts, socio-economic impacts, and the journey to vaccination. And Anita is a consultant of life sciences of Avertim. And I'm going to give the floor to Lucas Seringer first, who's going to tell a little bit more about the webinar, and then to Laura van der Tol, who's going to speak about Avertim. But not before I can tell you that you can ask your questions in the Q&A session, which is in the bottom of your screen. We will probably only come back to the questions at the very end, only if we see that's a very relevant questions for the topic itself. At the moment, we will come back to it right away. If not, we'll come back to the questions at the end. So do not hesitate to start asking your questions in the Q&A session. Also, we will launch a few polls. Those polls are anonymous, so do not hesitate to answer. We give you like 20-30 seconds max to answer, but it's nice if everyone participates because then you have the nice percentages. So again, it's anonymous, so do not hesitate to answer them. Well, we have a full program, so I'm going to give the floor to Lucas Seringer first, and I'm going to give you, I want to wish you a great seminar. Enjoy. Lucas?
Thanks a lot. Thanks a lot, Sylvie. I think you said it all, but thanks. We're very glad to be here. So my name is Lucas. I'm a French native, and I work for a Belgian company. Actually, I started in Brussels. I'm now based in Frankfurt, and I'm before you for an event in the Netherlands. So I think that already shows the quite international spectrum we're having at Avertim. I'm very happy to be here because when I started in 2016, developing Avertim in Germany, the company has expanded quite a lot, and I came to Frankfurt to open Germany. We actually worked quite a lot with the Chamber of Commerce and took part in different business clubs, French, German business clubs. So it's always good to be well supported and integrated by the communities while developing our activities and impact. So why this webinar today? Well, I think we are right now all looking to a brighter future. And of course, we need to turn to the post-COVID mode, but also turn this pandemic and crisis into opportunities for our people, for our society and businesses. In the summer last year, we actually started a COVID tracker publication. That was a weekly publication where we were always giving updates on what's going on in the COVID-19 space. At the beginning, people talked a lot about clinical research and clinical trials. So all my friends and my family members, they became clinicians, professionals. But there was a lot of question about that. Later on, it became questions more about supply chain, the cold distribution, and then manufacturing. And now we're still talking about manufacturing and quality issues. So I think we've been in a very good spot as a preferred partner for life sciences company and especially pharmaceutical companies to observe these trends. And we saw it evolving actually since a year. And I think it was a good time today to discuss it with you, reflect on some sectors of impact. Of course, the life sciences, where Anita will give a focus, but also covering all the industries where Avertim is active. So perhaps the first question you have is, who is Avertim? And for that, who best than Laura, our local Avertim lead in the Netherlands. So Laura, perhaps you can say a few words about yourself and also about Avertim.
Sure. Thank you, Lucas, for that nice talk and also introduction. So welcome, everyone. First of all, I'm very happy to see so many participants here today. It's great to see all of you interested in our webinar. So I'm Laura indeed, Senior Manager Country Lead for the Netherlands, and actually very proud but also happy that we as a company can provide you some insights today on the topic that I think all affects us, COVID-19. But as Lucas mentioned, and Sylvie, by the way, as well. So who are we? So I'll give you a bit more insight about our company before we really start with the webinar today. If you look at the next slide, we are a consulting firm and we are active in different sectors. So we truly believe that the connection to make between strategy and operations is vital for everyone's success within a company. And we do that within 3 different service lines. So we do that by increasing performance at our partners, where we really help our partners to achieve their goals and priorities. The second one is that we aim to drive on innovations, where we really are looking to identify new trends and to help our partners to profit from those trends. And the third one is compliance, where we are really looking at constraints, but making that a competitive advantage for everyone. So when you look at the next slides, we are actually founded in 2007 by our CEO, Hervé, and we are really proud today that our company consists of 300 consultants, where the most of us have 8 years of experience, where we really can bring professional expertise at our clients. And we do that in 5 sectors, as Sylvie already explained. So we do that in banking and insurance and life sciences, transport, energy, telecom and media, and we will touch some of those sectors also today. As Lucas mentioned, we are very internationally orientated, and as you can see, we are actually working from our headquarters in Brussels, but also opened up our offices in Amsterdam. We are in Paris situated and in Frankfurt as well. So last but not least, I wish you all a very nice seminar and I hope you enjoy it. And then I give the floor to Anita. Thank you.
Thank you, Laura. Welcome everyone to this webinar. My name is Anita van der Zwan, and as mentioned by Sylvie, I am a life sciences consultant for Avertim based out of the Amsterdam office. And I finished my PhD in immunology last year, and over the summer of last year, so during the pandemic, started working for Avertim as a consultant. And I'm excited today to share with you the socio-economic impacts of COVID-19, and thereby also the journey towards the vaccine. So let's jump right in. So most of you probably remember around February, March of last year, when the first cases of COVID-19 started emerging in Europe. I don't think any of us had any comprehension of what this would mean in the long term for our economy, for our healthcare systems, and also for our daily lives. People started making a run for the supermarkets, stocking up on toilet paper, mouth masks, and painkillers. Now, we're more than a year past this point now, and looking back, what has been the impact of COVID-19 on the world as we know it in the Netherlands? So let's start with the banking sector, which is, as mentioned, also one of the sectors that Avertim is active in. So in March of last year, the European Commission set up a temporary framework that enabled the member states of the European Union to set up direct grants or tax advantages of up to 500,000 per company, give subsidized guarantees on bank loans, and also enable public and private loans with subsidized interest rates. Also, this new temporary framework that was set in place recognized the importance that banks would be playing in dealing with the economic effects of COVID-19, and especially in aiding their final consumers, being the small and medium-sized enterprises. So now, what has been the impact of COVID-19 on our economy and thereby also on the financial sector? And I would like to start off this section with a poll. So I give it over to Lucas.
Yes, so normally you'll be able to see on your screen a question popping up. Exactly. How much did the Dutch government spend on COVID-19 support packages? As Sylvie mentioned, there will be 3 or 4 polls during the presentation to keep you active and engaged. We haven't decided on the prize for the winner yet, but it's going to be anonymous. So please submit your answer. How much did the Dutch government spend on COVID-19? And please don't use Google to do your research. I think we're just giving 5 more seconds and then we can close it. All right, can we see actually the answers that was most given by the participants? 55, okay, so 40% of you said 55. The answer was actually number 346. And I think Anita will tell us a little bit more about that.
Yes, indeed. I guess the number is indeed a little bit more optimistic than 40% of the audience thought. So it was 46 billion. The impact of COVID-19 on the Dutch economy is quite comparable to the situation during the financial crisis of 2009. If we look at this graph on the left-hand side and focus on the blue line, we can see that in both years, so in 2009 and in 2020, the Dutch economy shrunk by approximately 4%. If we now put our focus on the gray line, we can see that the overall Eurozone went through a bigger dip last year than it did during the financial crisis of 2009. The European Central Bank and the Nederlandse Bank are quite optimistic that our economy will have a turnaround. And this is mainly due to recovery packages that have been offered by the Dutch government. So as mentioned, the answer to the previous poll was 46 billion euros has been made available in support for businesses, entrepreneurs, and employees. At the same time, the Dutch government suffered a loss of approximately 17 billion euros in tax revenues due to tax deferrals to the general population. This resulted in a negative balance over the year of 2020 of 7%. So what now do these positive outcomes do we get from these support packages that have been provided by the Dutch government? For example, the households, the businesses, and the international trade. If we first take a look at the households. So in the Netherlands, normally households account for 50% of the overall spending. What is interesting is that last year, about 42 billion euros was saved more in comparison to 2019. So basically, Dutch citizens were keeping all of this money in their savings account and not spending it on the economy. During a pandemic such as this one, you usually see a quite steep increase in the unemployment rates. But thanks to these support packages that were offered by the Dutch government, approximately 1.3 million people in the Netherlands received salary support from the government and thereby did not lose their job as their jobs got subsidized. If we look at last year in the Netherlands, there was even a slight decrease in the unemployment rate between October and December. People are afraid, though, however, that once these recovery packages by the government are terminated, that the unemployment rates will go up. Now, as of last Saturday, actually the 5th of June, the measures in the Netherlands have eased quite a bit. And it is expected that the Dutch citizens will go out again, go to restaurants, go to museums, and spend money on their vacations. And all of this spending in the economy will result in a strong rebound in the coming year and in the coming future. If we now look at the positive outcomes for businesses, throughout the year of 2020, there was actually a decrease in corporate investments of about 4%. But thanks to increased confidence in the economy, this is expected to have a turnaround of approximately 3.5% in this coming year. What does this mean for the government? So as we discussed during the poll, the government already spent about $46 billion on these recovery packages. And the government is expected to spend even more in the coming months to come, as they need to catch up on the deferred hospital care. As we all know, during this last year, all the priority went to the COVID-19 patients, and so hospital care for other patients was often deferred. They now need to catch up on all this hospitalized care, and of course, the deployment of the vaccine is costing the government a lot of money. At the same time, the question that arises now is, when should we stop with these recovery packages? Some argue that we should do it in a gradual fashion, to actually prevent a shock effect where companies will not be able to pay their bills anymore. Others argue that these recovery packages must be stopped immediately as they hinder the economic recovery. So a question that popped into my mind, and maybe a question to some people outside of the financial sector in the audience, is where does the government get all of this money? This money is basically borrowed from government bonds that are bought by banks and pension funds. So these banks and pension funds buy the government bonds. This basically replenishes the so-called pot of gold of the government. They can then use this money to push it into the economy. And that is how in the last year, the Dutch government has been keeping our economy relatively stable. Of course, this money that the government loaned will need to be paid back in the near future at an interest rate. And here we see a picture of what is currently going on, the vaccination being rolled out at the GGD in the Netherlands. Lastly, what has this meant for international trade? So we all know that during this last year, there's been quite a strain on the supply chain coming from Asia. And here we see the incident of the tanker that got stuck in the Suez Canal. However, international trade is expected to have a strong rebound on both the export and the import side of approximately 6%. So far we've looked at the role that the government has played in keeping the Dutch economy relatively stable. But what has been the role of central banks and the consequences of their measures for retail banks? So the primary function of central banks such as the Nederlandse Bank and the European Central Bank is to monitor the financial stability of the countries within the European Union. And so over the last year during this pandemic, they have implemented several supervisory measures to actually warrant the stability of the Dutch and European economies. So some of these measures are indicated here on the slide. The first one being lowering the buffer requirements. The second one being higher capital requirements were postponed. And thirdly, no dividends were paid out in 2020. And caution is being taken in 2021 to pay out dividends now. These three top measures actually allow Dutch banks to have more capital and more cash reserves to actually lend out more loans, and also at the same time absorb losses from existing ones. A fourth measure that was set up by the European Central Bank are credit support measures. This basically means that they offered banks long-term funding at very attractive rates to stimulate bank lending in the economy and thereby give the economy a push. The last measure is that the European Central Bank launched the Pandemic Emergency Purchase Program, the PEPP, to maintain financing of the real economy. Now, what this program basically entails is that it requires national central banks to buy bonds. And that brings us back to the previous slide. Once these bonds are bought, new money is put into the economy. So what do all these measures now mean for the local retail banks as we know them? And what does it mean for us as individual consumers? So the first thing for retail banks is that these measures that were put in place resulted in healthy capital ratios. This is the ratio of a bank's capital to its risk. What this means for us as individual consumers is that over this last year, it has remained possible for us to actually obtain credit. And this was very apparent in the housing market in the Netherlands. As you probably saw around you, people were going crazy in the Netherlands, buying houses, loaning money from the bank. And so because of these measures, we were all able to do that. The second implication for retail banks is that their profitability will most likely decrease due to increased provisions by the central banks. And because of this decrease in profitability, retail banks need to start cutting costs. And they can do this by closing down the smaller retail banks, the smaller branches within their banks, and also to prepare for possible industry consolidation. Retail banks also need to fully accelerate their digitalization. What this means for us as individual consumers is that we will be more and more exposed to digital banking services. And what is quite interesting to note here is that the loyalty to retail banks has actually decreased in the last year. 36% of consumers indicated that they switched their financial services from the traditional retail banks to big tech and fintech. So much for the banking sector. Now let's move on to the transportation sector. As we have seen around us, travel has been in hibernation, and this has resulted in massive job and revenue losses. If we only look at the public transportation provider, the NS in the Netherlands, its ridership over the last year dropped by 90%, from 1.3 million to 110,000 riders per day. And the NS anticipates that it won't fully recover until the year 2025. A recent study in the Netherlands also showed that about 1/3 of the Dutch population indicated that they will be using public transportation less after the pandemic. And part of this has to do with the shift from public transportation to cars. People feel more comfortable in their own car, not being exposed to other riders on the train or on the bus. So unfortunately, today, we don't have enough time to go into all the different aspects of the transportation sector. So for now, I would only like to focus on the automotive market in the Netherlands. And to start off this section, let's launch another poll. Over to you, Lucas.
Yes, so same way, I think now you know the process. By how much did the sales of electric vehicles increase in the Netherlands in 2020? So we're looking at the sales increase for EV in the Netherlands in 2020. Do you think it's 15, 20, 25, 30%? Apparently it's more than, it's at least 15 if my guess is correct. So we're talking about a good growth, but how much is it? Okay, so I think you're all seeing the panel, the poll panel, so you should be able to answer, and we will soon see the results of your votes. All right. I think we can display the results probably. And you all said 25%. Actually, the answer is 20%, which is already a quite good growth for the EV market in the Netherlands.
Yeah, that was a pretty good guess, not far off. Indeed, the penetration of electric vehicles has increased by 20% in the Netherlands. So let's look at the impact of COVID-19 on the automobile transport in the Netherlands. So the next two pictures are probably not very surprising to you. If we look on the left-hand side, we see the situation on the Dutch highways before COVID-19. As we all know, there are too many cars in the Netherlands for the number of kilometers of highways that we have. And on the right-hand side, we see the situation during COVID. Hardly any cars on the road. During this last year, congestion decreased by 90% and overall traffic volumes dropped by 50%. So what do all these sudden changes in car travel now mean for society, for consumers, for the automobile industry, and also for the government? So let's start by looking at society as a whole. So working from home is most likely here to stay. And 27% of Dutch citizens have indicated that after the pandemic, they would like to work from home more often. This will obviously then result in traffic volume decreases and result in better efficiency of the transport system and also time saving for travelers, resulting overall in happy travelers. If we take a look at the impact on the individual consumers, over the last year, we have seen a trend towards individual consumers rethinking their personal mobility. More people were spending time at home, restaurants were closed, museums were closed. So what else was there to do than to bike? Interestingly, biking in the Netherlands went up by 50% over the last year, and bike sales actually went up by 30%. And what was quite interesting for me to know is that, and probably for you also, that in the Netherlands, there were even shortages and waiting lists for bikes. Can you imagine in the #1 biking country in the world? What has been the impact on the overall automobile industry? So as you can imagine, it was very badly impacted by this pandemic. Not only were there major reductions in sales, the sales of new cars dropped by 20% over the last year, but there were also issues with the supply chain, with parts for car production coming from, for example, Asia. A turnaround is, however, expected, where we expect the sales of new cars to increase by 10% in the next year. And as mentioned, an increase in the electric vehicle penetration in the Netherlands, hereby putting the Netherlands in spot #2, right after Norway, when it comes to electrical vehicle penetration. What does this mean for the physical dealerships as we see them here on this photograph? They will most likely be decreased or at some point even completely taken away, given the current situation where people can go onto their mobile phone or their tablet and look at 3D models of cars and basically from your couch decide which car you want to buy. Another thing that is quite interesting to note here in the automotive industry is the car sharing concept. So before the pandemic, this was actually increasing. People were seeing this as a sustainable way of traveling. However, we now see a trend towards a decrease in car sharing. As mentioned before, due to the pandemic, people do prefer to stay within their own car and not be exposed to risks of infections by sharing their car with other people. If we now look at the impact that it has had on the government, as mentioned, the increase of electric vehicle penetration within the Netherlands is obviously going to decrease the taxes that we all pay over our gasoline prices. So overall, what we can conclude here is that the automotive industry is bound to radically change from the supply side and the demand side, but also from a regulatory side. And this is mainly due to the penetration of electric vehicles. Now let's jump right into the next sector and also the last sector that we will discuss here, the energy sector. So overall, electricity demand has decreased over the last year and is expected to remain lower as commercial buildings, factories, and other large electricity users have slowed down or completely stopped their operations. Residential use, on the other hand, is expected to rise as working from home is becoming more and more a norm. So now let's look at a shift in the energy consumption as a result of COVID-19. So if you look at the graph on the left-hand side, the year 2020 is indicated in red, whereas the year 2021 is indicated in light blue. Now, if we focus on the left column, we see the global CO2 emissions. And throughout the last year, throughout this pandemic, there was a decrease of approximately 6% in CO2 emissions. This was 5 times greater than the pullback that was observed during the financial crisis of 2009. The principal driver for this was that the decline in emissions was more than actually the decline in energy demand, and that the traditional energy sources such as oil and coal got hit very hard. It is important to mention here that even though there was a decrease in CO2 emissions, we are still at an all-time high when it comes to CO2 emissions. And unfortunately, a rebound is expected of about 5% in the coming year. If we look at the traditional energy sources such as coal, natural gas, and oil, they all experienced a decline over the last year, but also here a turnaround is expected and an increase of these energy sources will probably happen in the near future. One good thing that came out of the COVID-19 pandemic in terms of energy sources is actually looking at the renewables, which you see on the right-hand column of the graph. The renewables actually had an increase of 3% over the year 2020 and are expected to have a further increase in the coming year. The strong upward trend is mostly going to be caused by wind and solar energy that contribute to 2/3 of this growth. So we can conclude here that renewables are perhaps a success story of the COVID-19 pandemic. So the question whether the COVID-19 crisis will ultimately help or hinder the efforts to accelerate the energy transition and reach international energy and climate goals will very much depend on the actions that are taken by the government. Now let's look at different factors that could have played a role in the slowdown of energy transition in the Netherlands. Let's start by looking at the financing of renewable energy projects. So the ambition is to reduce the CO2 emissions by 30% compared to 2018 in the year 2030. And by 2050, the ambition is to have it completely CO2 free. This should mainly come from scaling electricity production from renewables, where wind and solar energy will play a dominant role. Currently, the problem, however, is that energy prices are still too low. And therefore, for example, the wind industry, the wind parks don't make any profit and are still strongly reliant on debt financing and on subsidies from the government. If we look at the second indicator here, the supply chain, as previously mentioned, the supply chain was severely hindered due to this COVID-19 pandemic. And it not only affected the automotive industry, but also affected the supply chain of wind and solar technologies, as 75% of deliveries for these energy sources need to come from China. So on the one hand side, we have a problem with financing. Secondly, we now have a problem with the supply chain, and in particular, the critical metals. These are, for example, needed to build the wind turbines. And unfortunately, these critical metals are not available within the European Union and therefore need to be sourced from the outside. The third problem here is that currently global demand exceeds the current supply. Now let's look at what it means for, or what the impact has been on consumers and businesses. So according to the climate agreement in 2019, 50,000 houses this year, and from this year onwards, 200,000 houses in the Netherlands need to be improved when it comes to sustainability. But what we saw over the last year is that many consumers and businesses actually delayed or completely canceled their investments into sustainability due to uncertainty about jobs and revenue. And also in this situation, consumers and businesses are still very much dependent on the government when it comes to subsidies for sustainability. Now, lastly, let's look at the financial markets. Let's end it on a good note here. So when we look at the green companies, it's interesting to see that companies that have been involved in the energy transition were actually less affected by the stock market crash than the more traditional financial companies. And this indicates to us that the energy transition is here to stay, as investors see enough of a future in these green companies to even invest in it throughout a pandemic. So the conclusion here is that companies with a focus on climate change or social responsibility performed and still tend to perform better than other more traditional companies. So government intervention is needed to keep the energy transition up to speed. But what kind of measures are we then talking about? So let's walk through these 4 indicators and measures that can be taken by the government to prevent a slowdown of energy transition. When we look at the financing of renewable energy projects, it needs to abolish indirect subsidies to fossil fuels and at the same time implement a CO2 tax. We need to continue with subsidies or introduce a minimum price for renewables. Looking at the supply chain situation, we need to accelerate the supply chain certainty of critical metals that are important components of the wind and solar industries, and accelerate recycling capacity. When it comes to consumers and businesses, the landlord charge needs to be abolished. And the budget that we gain from this can then once again be used to make housing more sustainable. The government needs to set up awareness campaigns and stress the benefits of sustainable homes, and hereby also recycling, and impose green conditions on COVID-19 support packages. And as you can imagine, when we look at these green companies, indirectly, the deferral of the CO2 tax negatively impacts the green businesses. Now, if the government actually goes ahead with these measures that are needed to avoid an energy slowdown in the Netherlands, what are the implications of these measures for society, consumers, the industry, and the government? To give you an example for each of these 4, when we look at society, one of the implications will be the polluter pays principle. This is a commonly accepted practice that those who actually produce the pollution should also bear the costs of managing this pollution to prevent damage to human health and the environment. If we now look at individual consumers, a carbon tax, for example, will incentivize us to avoid the use of fossil fuels. At the same time, this will most likely result in products becoming more expensive. If we look at the overall industry, a carbon tax will incentivize manufacturers to switch to renewable energy sources, but this then needs to be implemented at a European level, because otherwise you can imagine companies will just relocate to another country where there is no carbon tax. And then lastly, what this means for the government is, as we discussed during the automotive industry, they will be losing out on taxes that are now charged over the gasoline prices for cars. So they can compensate for this by implementing a carbon tax. And the money coming from this carbon tax should then be used to set up awareness campaigns for recycling and also to support citizens in renovating their homes. So up until now, I have discussed with you the socio-economic impact of COVID-19, how it has affected different industries, and how it has affected us as individuals living in this society. So what is next? So I'm happy to tell you that there is light at the end of the tunnel. And so for the next part of the presentation, I would like to focus on the journey to vaccination. How were these vaccines developed? How are they approved? And how are they distributed over the world? So let's start by looking at the 2 types of vaccines that are currently on the market. Most of you will most likely know that the vaccines that are currently on the market are the viral vector vaccines and the mRNA vaccines. So let's take a closer look at both of these vaccines and how they differ from each other. So if we start on top with the viral vector vaccine, we can see that this vaccine was made by extracting the genetic material from the virus So you can imagine us as human beings are made up of DNA that makes us unique. And in the same way, a virus has its own genetic code that makes it unique. So this genetic material was extracted from the virus and then implemented in an adenovirus that functions sort of as a carrier. So putting this genetic material into the adenovirus and adding additional stabilizers and salts, the vaccine was developed and could be used to inject human beings to prevent getting further infected with COVID-19. The two companies that worked on the production of these viral vector vaccines were on the one hand Johnson & Johnson, and on the other hand AstraZeneca in collaboration with the University of Oxford. Now, if we shift to the lower part of the slide, let's take a look at the mRNA vaccines. So also here, the same genetic material from the virus is extracted. But in this case, it is directly mixed with stabilizers and salts into a vaccine. The companies that were involved in putting these mRNA vaccines on the market were Pfizer in partnership with BioNTech, and secondly, Moderna. Now, once this vaccine is injected into your body starts making antibodies against it. So basically what a vaccine does is it educates your body. It primes your body. So the next time you actually get infected with the real COVID-19 vaccine, your body will recognize it and will immediately attack and eradicate it. Now, the question that has been going around in society, you must have heard it when you at work or with family members, the question of how is it possible that these vaccines were developed so fast? And is it safe for us to use? So for the next couple of slides, I would like to walk you through 4 reasons why the COVID-19 vaccine development is different and faster than previous vaccines. The first reason being that money, resources, and public were all in the right place. When we speak about public being in the right place, this is the fact that this is a global pandemic and everybody in this world has been affected by this COVID-19 virus. And because of this, countries came together and governments put in a lot of money to support pharmaceutical companies in producing these vaccines. Whereas usually money seems to be a limit for pharmaceutical companies to develop vaccines or other drugs, in this case, the limiting factor was definitely not money. And thirdly, resources were in place. Clinical trials were conducted at 100 sites across the world and very fast data, therefore resulting in data being gathered really fast. The second reason here was that research to build on already existed. If we think back to 2002, 2004, there was an outbreak of SARS-CoV-1 in China. And in 2012, there was an outbreak of MERS in Saudi Arabia. At that point in time, researchers already dove into these viruses and started researching them. So there was already some groundwork done into these viruses. And when the pandemic hit last year, this research was sort of taken out of the closet and was continued with. During the Ebola crisis of 2015, we realized that we were as a world quite unprepared for global pandemics as the current one. And so a global partnership was put in place, the so-called CEPI, a partnership between public, private, and civil society organizations that work to accelerate the development of vaccines against emerging infections. So since 2015, this organization has been in place and could now be utilized during this global pandemic. The third reason is that the vaccine technology was already in place and already existed. If we think about the adenovirus that I just explained to you, the vaccine that was produced by Johnson & Johnson and AstraZeneca in collaboration with the University of Oxford, this adenovirus that was used by Johnson & Johnson is actually the same technology that has been used a couple of years ago for the Ebola vaccine. So indicating that this technology already existed and was now used to develop the COVID-19 vaccine. What also really accelerated this process was the fact that the whole genome of the virus, so basically this same genetic material of the virus, was published in January of last year, giving scientists a basis to quickly develop these vaccines upon. The last reason here is the lean administrative processes. What usually extends the process of vaccine development is the rigorous regulatory entities that need to evaluate the data and give their approval. Because of the global pandemic, the process of the submission of data coming from clinical trials to regulatory entities was enormously sped up. Everything that was involved with the COVID-19 vaccine development got prioritized over any other drug developments. And a second thing that played an important role here were so-called rolling reviews. That basically means that regulators were provided with data on an ongoing basis. And I will explain this to you further in the next slide. But what this basically means is that we're in a standard procedure, procedure A needs to finish before procedure B starts. In case of a rolling review, procedure B already overlaps with procedure A. And let me explain this further to you when we walk through the drug development pipeline in the next slide. So how are drugs generally divided, vaccines and drugs developed, and through which steps do they need to go to actually end up on the market and to be injected into human beings? The first step is just pharmaceutical quality. Throughout the whole process of drug development, quality needs to be maintained in every step. The second step is non-clinical research. This basically means that vaccines need to first be tested in animals to check for safety and also to check for metabolism, to make sure that it is all safe when it is injected into a living organism. Once all of that is okay, we move on to the clinical trials, where the vaccines are now injected into human beings. Clinical trials are traditionally divided into 3 phases. We have phase 1, where a small group of healthy volunteers is injected with the vaccine. We have phase 2, that is where a small group of patients are injected. That's a group of about 100 to 200 patients, and they check for safety and effectiveness of the vaccine. And in the third phase, the phase 3 clinical trials, bigger groups of patients, up to thousands of patients, are investigated by injecting them with the vaccine and looking into the safety, the effectiveness, but also into the side effects. If all of this data looks good, it is sent to the regulatory entities and undergoes scientific evaluation and authorization. And in the standard procedure, only once this authorization is given, can large-scale production start. The last step in this drug development pipeline is sometimes referred to as a phase 4 clinical trial. This is why when studies are still conducted after a vaccine is already put onto the market, to further look into safety and also to look into the long-term effects of a vaccine. Now let's compare these 6 steps in the drug development pipeline between the standard vaccine and the development of the COVID-19 vaccines. So in both processes, in every step of the way, pharmaceutical quality is maintained. If we look at non-clinical research, this process started a lot earlier than it traditionally starts, mainly for the reasons that I just indicated. There was already research to build on, and the vaccine technology already existed. If we now look at the clinical trials, the 3 phases within the clinical trials, we here can clearly see this rolling review that I referred to previously. Here you can see that the first step, so the phase 1 trial, was not completely finished before phase 2 started. However, throughout this whole process, data was correspondent to the scientific and the regulatory entities to make sure that all was safe before we continued on with the next step, phase 2 and phase 3 clinical trials. A lot of years were actually saved here in this process of this direct interaction between regulatory entities and the scientists running the clinical trials. If we look at the large-scale production, it's also interesting to note here that the pharmaceutical companies during this COVID-19 pandemic already started their large-scale production even before they received authorization from the regulatory entities. This is a very risky move for pharmaceutical companies because if a drug or a vaccine is not authorized, there's no point in starting this production. But because of the extent of this global pandemic and the money that these pharmaceutical companies received from several governments, they were able to take this risky step and already scale up their production even before the vaccines were authorized. And then the last step is, of course, as I mentioned, the studies that happen after commercialization of the vaccine to make sure that in the long run, it is also safe. So as indicated here, the whole procedure that the COVID-19 vaccines went through are the same steps as in the standard vaccine development. So no scientific shortcuts were made here. A lot of time was just saved by these rolling reviews. Now let's take a deeper look into the authorization and the evaluation of data coming from clinical trials and before a vaccine actually ends up on the market. So the first step in this process are the vaccine developers. the so-called scientist. They run the clinical trials and then submit the test results to the regulatory entities. So in Europe, that is the European Medicines Agency, abbreviated by EMA. The equivalent of this in the US is the Food Drug Administration, the so-called FDA. So they submit their results to these regulatory agencies that then further evaluate it. So within the EMA, scientific experts, and in this specific case, due to the pandemic, also a pandemic task force were put in place to carry out scientific evaluation of these vaccines. This enabled EU member states and the European Commission to take quick, coordinated regulatory action. After the EMA comes the European Commission. The European Commission then evaluates the review done by the EMA, and if it all looks good, if it is all safe based on the data, it grants EU-wide marketing authorization. The step after that is that it comes down to the national authorities. So in this particular case within the EU, every country on their own can now decide if they also find the data valid to approve the vaccine within their country and start setting up a strategy to actually roll it out within their country. And this is done on a national level, and that is also why it is so different between the different countries in the EU, because every country decides for themselves how they want to set up the strategy and roll out the vaccine. All right, so now we've spoken about the development of the vaccine, the two different vaccines that are on the market. The process a vaccine needs to go through in the drug development pipeline to actually be authorized and be put on the market. Now, how does this vaccine actually go from a manufacturing site of a pharmaceutical company to the muscle in your upper arm? So let's take a closer look at the COVID-19 supply chain and thereby also some distribution challenges. So the first step in this process is the production and the first mile of the vaccine. It is important to mention that throughout this whole supply chain, temperature plays a very important role. And I will come back to this a little bit later. So within this production and first mile step, these vaccines were mostly developed in developed countries. And it is expected that by the end of 2021, between 9 and 12 billion doses of these COVID-19 vaccines will have been produced. The next step here is air transport. So we're taking the vaccine from the production facility on a plane to its destination. Now you can imagine before the COVID-19 vaccine, the pandemic, vaccines were actually distributed 50% via freight and 50% in the belly of a passenger aircraft. So you can imagine you're flying to your vacation destination, to Latin America or to Mallorca, and in that same flight, at the bottom, together with your baggage, are vaccines that are being transported to different locations. However, as we have noted during this pandemic, international travel and hereby international flights and domestic flights were put on hold and came to a halt. And this formed a great challenge for the distribution of these vaccines via air transport. The next step here is customs and security. So you can imagine the vaccine being a very valuable product at this point in time. And it is very important to prevent tampering with the vaccines and theft of these vaccines. Throughout this process of customs and security, fast-track procedures were implemented. And working hours of staff, but also the curfew hours that planes are allowed to fly, were all extended to provide for 24/7 distribution. Now, within the last mile, the vaccines need to go within their country of destination to actually the population to be injected into our upper arm. So throughout this last process, the last mile and then the ultimate vaccination, temperature is of primary concern. So let's jump a little bit further into this temperature problem that is surrounding the vaccine distribution. Why is temperature such an important factor? If we look specifically at the mRNA vaccines, they do not like it hot. If we look at the mRNA vaccine developed by Pfizer and BioNTech, it needs to be kept at a minimum of -70 degrees Celsius to not degrade. If we look at the vaccine provided by Mrna, it needs to be kept at -20 degrees Celsius. So you can imagine that this then plays an important factor in the distribution of these vaccines. So I'm going to hand it over to Lucas now for another poll question about the temperature.
Yes, thanks, Anita. It's really interesting to go through it in detail once again. So the question is about vaccines distribution. Indeed, you heard that there's temperature fluctuation in the supply chain. So our question, it's a 1 million euros question, how many vaccines, according to you, are lost due to temperature fluctuation in the supply chain? So how many vaccines are lost? Is it 15, 30, 40, or 50%? And we should have the poll.
No, Luca, we do not have the poll for this, so maybe it's good that everyone is going to think for themselves what they think it is, and then you're going to give the answer.
Okay, so think about it. Is it 15, 30, 40, 50%? And you may think there is no way it's 50% because it would mean half of the vaccines are lost due to temperature fluctuation. And actually, well, it is. So Anita, back to you.
Yeah, indeed, Luca. I was pretty shocked when I saw this percentage the first time. The WHO reports that around 50% of vaccines go to waste due to temperature fluctuations, which is half of the vaccines. And now the next question that comes to mind is, of course, why is this the case? So I think just by looking at the pictures on the next slide, it will give you an indication of why so many vaccines actually go to waste. If you consider that 2/3 of the population lives in Africa, in Southeast Asia, and Latin America, and in other regions of the world that are unfortunately don't have very reliable infrastructure, you can imagine the struggle of getting these vaccines to the rural populations of these countries in a safe and also in a timely manner. So on the left-hand side, you see vaccines being transported by camel to rural populations in Ethiopia. On the right-hand side, we actually see a solar system that has been placed on top of a camel to keep these vaccines cool as part of the Camel Fridge project. And so 50% of these vaccines, due to the distribution to rural areas across the globe, go to waste due to temperature fluctuations, which is of course a huge number. And so you might wonder to yourself now, isn't there anything that we can do to prevent these vaccines from degrading due to high temperatures? And there are. There are a couple of methods that we can apply to actually prevent the vaccines from degrading. I want to walk you through these several methods by using an analogy of chocolate. So let's take a quick mind shift here from vaccines to chocolate. So imagine a vaccine being a chocolate bar. And just as there are ways that we can prevent chocolate from melting, there are also ways in which we can prevent vaccines from degrading due to high temperatures. The first method being modifying the mRNA building blocks of the vaccine. So in the case of chocolate, we can add butter or vegetable oil to chocolate to prevent it from melting very quickly. So in the same way, if we modify the building blocks of these mRNA vaccines, we can prevent them from degrading due to high temperatures. The second method that is being used are lipid nanoparticles. If you imagine chocolate being covered by a candy coating, such as the case with M&Ms, to prevent them from melting, the same can be done for these vaccines. So we can encapsulate them with lipid nanoparticles to prevent them from degrading. If we look at Moderna's lipid particles, for example, they have particular properties that allow these vaccines to be stored at only -20 degrees Celsius compared to the Pfizer vaccines that need to be stored at a minimum of -70 degrees Celsius. So even if we modify the building blocks of these mRNA vaccines or enclose them with lipid nanoparticles, there's still a high probability that they might degrade. And so the third method here is to freeze the vaccines. And freezing of vaccines is not an uncommon method. This has actually been done in the past for the varicella, for the zoster, and for the MMR vaccines. You might know the MMR vaccines from the vaccines that are given to babies, for example. The last method that is being investigated is to freeze dry these vaccines. So the freeze-dried vaccines are transported by refrigerator temperatures by plane to their destination, where water is added to these vaccines to rehydrate them before they're actually used to vaccinate people. Freeze-dried vaccines, examples of these are measles, rabies, and tuberculosis. It is important to note here that regulatory agencies will likely require additional evidence that these freeze-dried vaccines function in the same way as the traditional liquid vaccines. So we've now discussed the important factor in the distribution of these vaccines being the temperature. So it now arrives at the location, at the destination, and now needs to be rolled out within countries. So let's move on to the next poll question to see the vaccination rollout within different countries. Back to you, Lucas.
Yes, so, and I think here you see the poll question. So in descending order, how would you rank the following countries in terms of vaccination rate? So we know that some countries are a little bit ahead in the race. So if you think, for example, the US is first and then it's Israel in terms of percentage, then it should be answer number 2. So in descending order, how would you rank the following countries in terms of vaccination rate? In terms of the share of population that received at least 1 dose. I think I heard something like today or yesterday, there has been a bit more than 2 billion doses administered so far, with a forecasted demand of almost 11 or a little bit more than 11 billion actually needed for only 2021. Okay, I think we can probably close the poll and we see the answer: Israel, UK, US, NL. And actually that's the good answer. I think Anita, you'll give the exact number if I'm correct.
Indeed.
Okay.
So you have all been following the news quite closely, because that is indeed the correct answer. So let's look at the graph where we can actually visualize this. So here we see the vaccine rollout with these different countries, where on the y-axis you see the percentages, and they indicate the share of the total population that has received their first dose of the vaccine. And indeed, Israel is leading with above 60% of their population, followed by the United Kingdom, the US, and then the European Union. And within the European Union, we see that both France and the Netherlands closely follow this average line within the European Union. Now, why is it that Israel, the UK, and the US have such a higher percentage compared to the EU? So let's first take a look at Israel. So what Israel did is, from the start, it negotiated special terms with the manufacturers. And Israel was also willing to pay more for its vaccines than the EU. Israel paid 23 euros per dose, whereas the EU only paid 12 euros per dose. Israel also retained product liability, unlike the EU, who insisted that Pfizer continue to be liable for the safety of the product. So Israel basically, as a country, took on the liability of the product safety. Israel also has a digitalized healthcare system and agreed with vaccine manufacturers that it would provide it with all the data coming from the vaccination campaign. And of course, all this data is very valuable for pharmaceutical companies. So in return, the manufacturers committed to supplying Israel with vaccines up to the point where they were able to immunize 95% of their population. If we now look at the UK, in terms of Brexit, they got pretty lucky, because the British Health Agency actually approved the vaccines of Pfizer and AstraZeneca much faster than the EMA did in the EU. And so the UK already started vaccinating the first people within their population on December 8th of last year. And now if we take a look at the US set up public-private partnerships to facilitate and accelerate the development, the manufacturing, and furthermore, the distribution of these COVID-19 vaccines within the US. The FDA, so the healthcare agency or the regulatory agency in the US, was also a lot faster at approving these vaccines than the EMA. And during the Trump administration, they very rapidly set up deals with manufacturers to already buy in a lot of vaccines. The US started doing this in July of last year, where the EU only followed in November of last year. So all of these three players, Israel, the UK, and the US, took a riskier path, but it paid off. They have a higher percentage of their population vaccinated, where the EU chose to go a more conservative way. Now, even though the EU is behind these three countries, the EU is still very far ahead compared to developing countries. And I thought this was quite a striking picture of our world, where in green we see that the developed countries all have access to the vaccine, whereas indicated in orange and red, you see that the majority of Africa, or actually the whole of Africa, and some countries in Southeast Asia and in Latin America still don't have access to the vaccines. And so last year, this was something that I guess was already expected by the World Health Organization. And so last year they set up COVAX. COVAX is the most important worldwide initiative aimed to provide fair access to these vaccines. The goal of COVAX is to deliver vaccines, and in this case, free vaccines, to at least 20% of the population of the 92 poorest countries in the world. Unfortunately, a lot of the vaccines that were ordered by COVAX came from India. And due to the recent surge in infections in India, authorities there halted the large exports of the Oxford AstraZeneca vaccine. And therefore, the COVAX is now only able to deliver 145 million doses of vaccines to developing countries, as opposed to the 240 million that they intended to deliver. It is, however, crucial that also the people in developing countries get vaccinated, because if not, the virus will keep spreading in these countries, will start mutating, and will easily jump over to the rest of the world. I like this saying that I found in a newspaper article, that with a fast-moving pandemic like this, no one is safe unless everyone is safe. And so it is very important that also these developing countries get access to the vaccine so they can vaccinate their population. Now, one of the things that's currently under discussion and that has been in the news is how can we solve this problem? One measure that can be taken is to waive patent protection. So let's look a little bit deeper into these patents. 3 elements of the vaccine can be patented. The first one being the technology of the vaccine, the second one, the components, and the third one, the vaccine itself. And what are the requirements to give a vaccine a patent? The requirements are 1, the vaccine must be new, 2, it must be innovative, and 3, it must be, we must be able to duplicate this vaccine. So outside of the pandemic, the system of patents usually works quite well, as it protects the big pharmaceutical companies that invest millions of dollars and euros in developing new drugs. But today, and given the extent of this global pandemic, it is quite questionable whether this patent system currently is still valid. So let's look at some different perspectives here. If we look at the left-hand side of the slide and we look at the yellow color, we once again see that the developing countries are in support of waiving patent protection. These developing countries are suffering heavily from new spikes in infections. They have lack of hospital capacity, and so they really advocate for waiving these patents so that other countries can also start producing vaccines and they can get access to these vaccines. If we now look at the developed world, indicated here in pink, these mostly oppose the waiving of patent protection. An interesting country here is the US. So initially what we can see on this map is that the US opposed it. However, in May, the Biden administration actually put out an announcement that they were for waiving of patent protection. And this was, of course, highly praised by the World Health Organization. What about the European Union? So a statement came out by Macron from France, where he is under of the opinion that waiving patents will not resolve the short-term vaccine shortage. The waiving of patents should only come after there's an end to the bans on exports. In contrast to the US, the EU has actually exported 50% of its vaccine production. And so according to Macron, the problem is not intellectual property, but it is the production of the vaccines. If we look at a stand that Merkel from Germany took, she said that waiving patents could actually benefit China, a geopolitical rival. And so if we open up the patents, we would be helping China and not necessarily be helping the developing countries in need. What is the viewpoint of the pharmaceutical companies? The companies are actually producing this vaccine. So they fear that this whole system of patents will be undermined, as their whole business and profit model is built upon this patent system. And they say that waiving patents is not the solution, as the key problems here are to do with trade barriers, with supply chain bottlenecks, with shortages of raw materials, and also the transfer of knowledge and the building up of these production lines, which could take more than 6 months to set up this whole process to start producing vaccines. And so currently this whole debate about waiving patent protection is still under discussion, and I believe no conclusion has yet been reached.
Anita?
Yes.
May I interrupt you for a question? Because someone
Sure.
also asked if the free licensing of the vaccines would also help to overcome the temperature issue, in the sense that vaccines could be produced locally and therefore not be shipped all over around the world.
That's a very good question. And I think that will definitely help. As you indicate, if it is local, it does not have to be transported, and it's easy to bring to rural populations. I think the problem that comes into play that is also related to this waiving of the patent protection is that the pharmaceutical companies and some governments claim that it's going to take too long to set up these production facilities in developing countries. And we cannot guarantee the quality, and it will also take too long to transfer all this knowledge. So the faster way would then be to just produce it in the developed world and from there transport it. But I do think that's a very good point to consider here.
Okay, thank you. I see there's a couple of more questions, but we can take them afterwards. So if participants have also more questions to ask now, please do in the Q&A and we'll take them in a few minutes.
I have one more slide for you and then I'm open for questions. So bear with me for one more slide. And so now let's end up this webinar with what the current situation is in the Netherlands. So what is the Dutch vaccination strategy? So the Dutch vaccination strategy is actually focused on reducing serious illness and mortality. And the Dutch government hereby followed the recommendation of the Health Council. So what happens in normal times outside of a pandemic is that the number of healthy life years gained is the go-to criteria for vaccination strategies. However, due to this COVID-19 pandemic, the strain on hospital capacity is so great that the Dutch government has decided to vaccinate older people first and have this be the most efficient way to reduce the number of hospitalizations. So that's basically the reason why in the Netherlands, we started off with vaccinating the elderly people. Additionally, in the Netherlands, just as in Italy, it has been decided to first vaccinate the staff in healthcare and nursing homes, and only after that start vaccinating the patients and the residents. This is also according to WHO recommendation. And one last interesting thing to note here is actually something that the Dutch outbreak management team decided on last week. It is to now only vaccinate people that have been infected with COVID-19 in the last 6 months, to only give them one shot of the vaccine. Because scientific evidence has shown that if you yourself have been infected with COVID-19, that you're mostly immune to this virus and therefore only need one shot of the vaccine in the future. And so this is currently where we are at with the vaccination strategy and rollout in the Netherlands. I believe today they are vaccinating up to birth year of 1986. So we are going at a rapid tempo now in the Netherlands. And so hopefully over the summer, we can get our whole population in the Netherlands vaccinated. And this gives us hope for the way forward for a bright future where we can start attending soccer games again. The Euro Cup is about to start. We can go on vacations. I think a lot of people crave for traveling the world again. And we can all attend our favorite holiday in the Netherlands, King's Day, on the 27th of April. So to end it here on a bright note, I would like the audience for their attention, with bearing with me through this long webinar. I hope it was interesting enough for you to sit it through. I would like to thank the Chamber of Commerce very much for inviting us to host this webinar to its members. And last but definitely not least, I really want to thank Maxime Walzinski, who put a lot of time and effort into researching all the data that was presented to you on the slides today, and also by making the slides for this presentation. And so with this, I leave the floor open to you and can take any questions. Thank you.
Thank you very much, Anita, for your great presentation. I learned a lot, and I'm sure that a lot of people learned a lot. I see some questions in the Q&A. I also see a few questions in the chat, but please use the Q&A because it's easier to treat all the questions then. So if you have put a question in the chat, please send it in the Q&A so we can treat it. I'll leave the questions to you, Luca. Are there any more?
Sure, I would do perhaps starting with the last topics regarding vaccines. We still had some questions about that. We talked a little bit about waste and vaccines waste in the supply chain. There was also a question from Adrien related to specifically the waste and percentage of waste of the Janssen and AstraZeneca vaccines. So Anita, if I'm not mistaken, we don't have the exact data. Actually, I think it's quite difficult to have a consolidated data on the waste of specific vaccines. What we know is that there's a number of events that can cause waste, such as indeed transportation issues. We read reports that, for example, in Hong Kong, it is said that the government is stocking too many vaccines and that the population may actually not take it. I think it's a little bit the fear we have for the Janssen or for the AstraZeneca vaccines in Europe, that in some of the countries, population will not take it. I don't know, Anita, if you want to comment on the waste on these specific vaccines.
Yeah, I think you're right. I mean, we know, for example, for the Netherlands that we are getting the most of the Pfizer vaccine because it is the highest in supply. And then secondly comes Moderna, but it is a lot lower in supply and in circulation compared to Pfizer. And then, as you mentioned, for AstraZeneca and Johnson & Johnson, so the Janssen vaccine, they have now actually decided to only vaccinate the elderly population because of the rare side effects that were observed in terms of the blood clots. So that is also a method of waste, that these vaccines are now not being used.
There has also been a report of a mix-up in production processes from Janssen, which caused the waste of 15 million doses, which is actually a very, very high loss. But with such a fast pace and a rapid development of manufacturing units, there are deviations, there are some quality issues. Some of our teams are busy working on that, but there are very high quality constraints, which makes then the bar quite high, and therefore some doses and batches have to be simply thrown away. Okay, we had a question about the lipid vesicles that you presented before. Are they primarily used to prevent degradation in higher temperatures or to deliver them into the human cell? So basically, do they protect for temperature, or is it more a delivery issue?
From the information that I have, these lipid nanoparticles are mainly used to protect from temperature, and are not necessarily needed to inject it into a human body.
Okay, thank you, Anita. So some people, and I see Fred has asked the question about very long-term side effects of the vaccines after 5 or 10 years. Of course, everybody is thinking about this. There are discussions, and we see a lot of people on TV discussing and debating about that. Is it even possible, Anita, to give 100% truth right now to the audience? But what is your take on that? How can we guarantee, safe vaccines after 5 or 10 years, or what's going to happen?
So yeah, that is of course the question of the day. We are all being vaccinated at the moment, and where will we be 10 years from now? So I don't think we can say anything at this point in terms of the side effects that we will see in the next 5 to 10 years, because the data just isn't there. What I guess puts my head to sleep at night is what I mentioned, or what we mentioned in the presentation, that the technologies used for these vaccines have actually been used before. So for the Janssen vaccine, the adenovirus has been used in the Ebola vaccine, which was 5-6 years ago. And so far, I am not aware of any major side effects. And then if we look at the mRNA vaccines, mRNA was actually, I believe, developed 20 years ago in Germany and then brought over to the US. And so this technology has also been around for a long time. So that kind of puts me at ease, but at the same time, as Lucas also said, we don't know what is going to happen in 5 to 10 years. So unfortunately, I cannot completely answer this question.
I think there is a scientific consensus to say that side effects, if they are very low and very rare in the first month, the first weeks, and now we start to see population after even 6 months, if the side effects are very, very rare, it is very unlikely that they come after several years. Yeah. And it's the historical data and evidence shown by every vaccine so far. And the mRNA is not changing that element of side effects appearing in the human body. Yeah. Okay, so I'm looking at the other question. I see that there are more coming up. Great. Adrien asked, so we have some precautions taken by the European countries with the AstraZeneca. Oh, yeah, Anita, back to your slides. Okay. No worries. Will the precaution taken by the European countries with the AstraZeneca and Janssen vaccines to protect their population from extremely rare side effects also be applied for the population from the COVAX program? So do we give any guarantee to the local population benefiting from the COVAX program about side effects and safety for the population that will receive the vaccines?
And then you mean in terms of the guarantee of the safety, given that we are providing them with the AstraZeneca vaccine?
So, for example, about the liability because of, the power of national authorities, for example.
Yeah, so it is I guess it is the power of the national authorities that decide upon this, which vaccines they allow within their countries and which part of the population they decide to vaccinate. Is it only the elderly population with a certain vaccine or just all of them? I don't know if that completely answers the question.
Yeah. Perhaps that's an area where we have to do a little bit more research, and perhaps also the future will tell. As we know, on the COVAX program, a lot have been defined, but not yet really implemented due to a lot of issues, and also, of course, political game related to healthcare policies and prioritization. There's a question about, indeed, also about the safety. Was the decision-making process of the EU better in terms of safety? So I don't know in the question, Florian, better than what? Better than the UK or better than other countries? But Anita, can you say a few words about that? And
I think that is a difficult thing to say, because we have in the US the FDA, which is a pretty big organization, and then in the EU we have the EMA. And then, of course, we have the British health authorization in the UK. And then Asia has their own health authorizations. I wouldn't say that the EMA did a better job at evaluating the safety of these vaccines. They just did it in a different manner. So the FDA looks at different things. And I think the FDA often takes more of a risk than, for example, in Europe, we are more on the conservative side. But it can also be the other way around. Like, I've also heard of drugs outside of the vaccine that were approved by the EMA and then did not get approval from the FDA. So I just think it really depends on the scientific advisors that are on these boards and what their criteria are, which could differ between the countries for approving vaccines.
Do we have any sign that the EU will actually adapt its way of working in the future in order to be more reactive? Again, here, I don't know if the question is about the prevention, the masks, or is it also about the vaccines, manufacturing and putting vaccines into market?
That's a difficult question. I think in this case, only time will tell. I think we've had pandemics before, like with the Spanish flu or in the 1916s, but like in this day and age, this has been the biggest global pandemic so far. And so it could very well be that the EU has sort of learned from this. And so when something like this happens again in the future, that they will take quicker action. But that is not something that I am confident in giving an answer in, because I really do think time will tell. I don't know if you know more about the policies, Lucas.
Yeah, I've been looking a little bit at the EU programs. There's a program called EU for Health. It's a 9.5 billion euros, if I'm not mistaken, something like that, 9.5 billion euros that will be invested over the next 6 years, so until 2027, which will actually look at healthcare resilience. So there's a number of projects like the EU Commission invest in, for example, Horizon 2020, or other research and innovation projects. And this one will be especially for COVID resilience and healthcare resilience. So it's part of the COVID crisis response that they built. I don't know the details of all the sub-programs, but for sure there will be some about more reactive, more resilience, national stocks, and all these issues that we have seen at the beginning and also during the pandemic. For example, also standardization of manufacturing facilities and processes, standardization of technology transfer for critical drugs and vaccines. These are really key issues to react fast. Okay. We had one question also from Adrien. Actually, it would be a question for debate, but what about energy consumption in the future? Are we, I gave the answer that long-term forecast of energy, or actually forecasting energy growth, consumption of the growth of the energy consumption. But can't we use other way of, I don't know, traveling, consuming that are more energy savvy? Can we reinvent ourselves? Can less become more? Do you have a take on that, Anita? Or have you seen anything related to Netherlands policies regarding energy consumption?
So I do think that the Netherlands is very much looking into renewable energy sources, such as wind and solar energy. I think it's quite clear also when you look outside of this country, there are a lot of those wind parks, for example, in the North Sea and also in the IJsselmeer. So I do believe also with the elections that we just recently had, that there is a strong point on the agenda for sustainability and for renewable energy sources. I think recently, I believe it was last week, Shell was also very much in the news because of the restrictions they got and how they need to reduce their CO2 emissions by a significant amount, and actually higher than they initially wanted to do themselves. And this was ordered by a court. And so now a lot of other companies are fearing the same verdict as Shell just underwent. And so I do think in this case, the Netherlands is really working on this switch to renewable energy sources. And then if we look at transportation, I think for me, it was in a sense quite sad to see that this shift from car sharing, for example, is now going back to people jumping into their own car again. I understand it. You want to be in your own car. You don't want to touch the steering wheel that somebody else has touched. But that does mean that we are going back to the situation where it was before, where we don't want to do car sharing. Even shared mobility is now becoming an issue due to this pandemic. So I think in some ways the pandemic has helped, for example, with the renewable energy sources. But on the other hand, if we look at the automotive industry, it has also had an impact on several good things that were just starting up. However, if we do look at electrical vehicle, as we discussed in the presentation, the penetration of electric vehicles, we are second after Norway in Europe. So that is also an indication that the Netherlands is really focused on this. And so I guess that's a long answer, but yeah, is more or less. I would hope so for the future, and I would hope it would stay on the agenda also for the government here in the Netherlands.
Yeah. Thank you, Anita. We have a question, and I think that's going to be the last one. Do we have to do a yearly vaccine?
Yeah, that is a very good question that I think a lot of people are wondering about, given that the flu vaccine is something that we do tend to get every year. That's not sure, and I cannot really give you a definite answer here because it has not been studied enough and we don't have like long-term data. I think it depends on two things. The first one being the duration of immunity. Also here, because it hasn't been so long since people have actually been vaccinated, there's not enough data to suggest how long this immunity will last us. Is that a year? Is that 2 years? Or is it up to 5 years? So that is the first thing. And the second thing I think it really depends upon is variants. So how fast will this virus mutate? And therefore, do we need new vaccines? If we are, for example, now looking at this new Delta variant that has been coming up in the UK and that originated in India, I actually this morning read an article where they indicated that they found this Delta variant only in hospitalized patients that actually did not receive the vaccine. And they only found it in 1 or 2 patients that were hospitalized that were vaccinated. So this is a pretty good indication that at least at this point in time, let's see what the future will tell, that the vaccines that we currently have are also robust against variants that are popping up. But so I think it will depend on these two things in the way forward if we need a COVID shot every year or not.
I reviewed a forecast about vaccines, global vaccines market, especially for COVID. I don't know if you're aware, but there are the companies like Mrna, BioNTech, Covet, they had a combined turnover of $180 million in 2019. So $180 million is a very small number for companies like Mrna, BioNTech, and CureVac together. This company will help generate more than 50 billion of turnover in 2021. So I think the forecasts are estimating the market at $67 billion 2021. We're going to drop at 61 billion in 2022, and the estimation is about 8 billion in 2023, with probably late stages. There are also vaccines which are developed especially for a woman in maternity or pregnant woman and child. So we know that there will be new waves of the vaccines for 2021 and 2022 as well. With forecast until 23, but at $8 billion. As you say, Anita, we don't know what's going to happen in the next month. Okay, I think we're good with the questions. So thanks a lot for all the activity. I don't think I missed any.
Thank you, Luca, and thank you, Anita, and of course, Laura van der Tol. Thank you so much for being with us today, for sharing your knowledge, your expertise with us.
You.
It was a very interesting webinar. I think we could have gone on, but yeah, I think we have to respect time. We said 1.5 hours, so let's respect that. Thank you so much to the audience for being with us today. And again, the team of Avertim, you were great. Thanks so much for your preparation. You put a lot of time and effort in it, and you did a great job. So thank you so much, and I wish you all a great evening.
Thank you, Sylvie. Thank you all.
Have a good evening.